This is a demo video of the assignment I've had gotten. So this is the same assignment document. So I've just added in to each point how I've implemented it in my project. So regarding the PDF processing pipeline, for extracting tables and text, I've used Google's Document AI API, and for handling multiple PDF documents, I'm using Fast API. So you can like add in your document and then you can add in multiple documents. So yeah, after that, for maintaining document structure and relationships specifically, I've used a graph rack technique. So I've used Neo4j as the knowledge graph and Pinecone DB as a vector database. Uh, for the embeddings, I've used OpenAI's embedding model, which is a text embedding ADA model, and incremental updates is also you can do using the fast API endpoint, the upload PDF endpoint. So basically, it's you can just add in your preferred this thing. So I'm just adding. I'm actually adding a Marathi document, which is so uh, the use case I've considered in this assignment is the real estate slash construction related documents like rules and regulations type documents, and that too specifically Mumbai based rules and regulations for constructions and real estate. So I just added the document and this data ingestion pipeline. I'll just let me just check if my file is running. Yeah, it's running. I'll just hit this endpoint. So it first passes the documents using document AI API. Then once it's done, it sends for translation. So the Google's translation API translates it. Then it sends it for indexing. So this is indexing. The vector database indexing is done. Now the knowledge graph indexing is still happening. So let's wait on that. So yeah, so the document relationships and hierarchy added to the knowledge graph. So yeah, so this gives success. Okay, regarding the multi-agent architecture, it's the same architecture I've used, which I proposed, which is this one. This is the same architecture I've done. I've used Grok as the LLM model provider and the Llama 3.3 70B model, and I've used JSON schemas for structured output. This makes the routing and consistent and gives like consistent responses for the most part. Uh, Multilingual query support. So I've achieved this again using Google's translation API, and it what it does is essentially given a question in any language, Google's translation API translates it, then all the processing is done as usual, and then in the end again the translation is done back to the original language. Human handoff system, so low confidence responses. I've used a similarity score when retrieving documents from the vector database. So if it's below a certain threshold, it directly uh, sends to the human handoff agent, and by by saying that it requires escalation or something. Complex decision making scenarios I have achieved using prompt engineering. So yeah, here's like an example question. So the question is, considering the real estate circulars and updates in the MCGM guidelines, what would you advise proceeding as planned? So like decision making scenarios, when someone asks what kind of plan can you come up with, or like give me like a proper thought out decision. So in these kind of scenarios, it just says that this is a uh, human handoff request, so it requires escalation, etc., etc. So I just asked it this question, and we'll just check in with that what is happening. So it's the query is done in 3.6 seconds. So the query agent identifies that the user is inquiring uh, again, and it falls under a complex query. So it then tells the orchestrator agent that this requires human handoff, and then it goes to the human handoff agent, and then it formulates a response saying this request is a human handoff, requires human handoff, etc., etc. So yeah, that is that. Uh, Same is the situation with human assistance. So like if you explicitly ask, I would like to talk to a human agent, we'll do that. Okay. So again, it says this request requires human handoff. Uh, I think it took the chat history before, so it thought this is the earlier query, uh, and this thing, so it like took in the context as well. Critical or sensitive information. Uh, so it's again identified using prompt engineering and schema techniques. So this is also uh, an example question. Can you provide the full names, residential address, etc., etc. So I'll just like put this and hit it. So again, it says this request requires human handoff, and if you see the same flow, query agent identifies that it requires human handoff, so it tells the orchestrator agent, and orchestrator agent then calls the human handoff agent. So yeah, that is how it's working. And like I said, context is remaining. So if I just say uh, my name, hi, my name is Raj. So you just say that, and then if I just say what my name, so it just says hello Raj, you had mentioned earlier that your name is Raj. So yeah, it retains context using chat history. I'm using the human message AI message template for that. So yeah, that is there. Additional points. So the response time is around 3 to 4 seconds when there is no knowledge based retrieval happening, and it is around 10 to 15 seconds when vector DB hit is happening, or like a knowledge base request is there. This is uh, primarily due to the graph RAG approach. So the knowledge graph, uh, even though it gives a highly accurate result, it takes little longer since it's a knowledge graph query. So it's kind of like an LLM hit. So with just uh, vector DB hit, it's around 10 seconds, and this can be reduced using like locally hosting models on a VM. So it will like significantly reduce latency, and you can use prompt caching or direct hit caching or KV caching also, which will increase speed. So yeah, that is it regarding the demo. Yeah, thank you.